Hey scholars, welcome to chapter 20-3 when we look at pollution problems affecting groundwater. And this becomes extremely important because the majority of the water that comes into your homes and what you drink is usually groundwater. So that is why this becomes extremely important. It is a source of drinking water for 50% of the United States population, but some of the most common pollutions or pollutants that affect that are fertilizers and pesticides, as well as gasoline and also organic solvents, which are organic materials that have leached all the way through into the groundwater. Pollutants dispersed in a widening plume. We call this a plume. Where there's a bunch of pollutants that are actually flowing through the underground water system. We call that a plume. It's a mass of flowing underground pollution. The reason why this impacts groundwater can't really cleanse itself, because number one, it does move, but it flows very, very slowly. So the contaminants don't really get diluted very well. It also there's less dissolved oxygen, so there's fewer decomposing bacteria. So it kind of just sits in there and then waits to be extracted when we extract it for groundwater. How long does it take to cleanse itself? Well, it's very, very slow, degradable. As far as waste goes, it can be hundreds of years as far as it cleansing itself. We'd have to go in and pump it out and clean it ourselves. It also can tamper with non-degradable waste like lead and arsenic, and the slowly degradable waste like DDT. So let's take a look at it. This is we're going to look at some different things happening here. So we have a hazardous waste injection well that if you're trying to deposit waste deep below the surface, if there's any leak from a faulty casing or like cracks at all, that can get into your aquifer. This is an unconfined freshwater. There's a confined freshwater aquifer. There's a pumping well, which we're stepping into. If the sewer it cracks or something leaks there, it can go into your aquifer and be taken up that way. Or a gasoline or tank solvent from an old gas station. If that cracks or leaks out, that can get into your aquifer, and all that can then be put into the same water that you drink or comes up for using for your homes. So that's kind of the scary situation. Also, a septic tank could do that too. If a cracked septic tank happened, that can be another problem with your water. Other water waste lagoons from animal farms like pig farms, chicken farms, ice from the roads, coal runoff or mining. All of those things could tamper into the aquifer, and those can all get drawn up with our water pump or our wells. This is a plume. This is what a plume looks like. So in this case, we have a leaky gas tank at a gas station, and that is leaking out through the ground. It gets down into the aquifer, and it becomes this large plume. Well, as it moves, because water does move as far as elevation in a water table goes, and it flows this direction in this case. And what happens is it can be migrating vapor. It can actually migrate in vapor up into basements, or it can be extracted in a water well like this one in this house, and it's tapping right into that resource. And even though that might be miles away, that water, that gasoline that's coming from the leaky gas tank, can get all the way into this person's drinking water in their house. So kind of a scary thing as far as leaking contaminants to groundwater. Oops. So groundwater pollution is a serious threat. China, many contaminated aquifers or overexploited aquifers. 9 out of 10 cities are contaminated or overexploited. The U.S., the FDA reports of toxins found in many aquifers, and a lot of times it comes from underground storage tanks like gasoline, oil. We're seeing methyl tertiary or butyl ether, which is MTBE, nitrates, cancer-causing things that are actually being leaked out because of storage, faulty storage tanks into the groundwater, and then taking up, and we ingest that with our drinking water. There's also sources of arsenic in the groundwater through mining and the oring process. If that runoff gets into the groundwater, we're taking in heavy metals. And those things can cause skin, lung damage, bladder damage, cancers in those different areas as well. A study in 2006 from Rice University was working on purification systems removing arsenic. I'm trying to find that here. There we go. 2006. Nope, didn't find it. I lied. Lost my place. Anyway, in 2006, Rice University had been working on a purification system to help remove arsenic as far as as far as allowing that into groundwater. So that might be at least something going on there to help us out as far as removing those heavy metals. Also, pollution prevention is the only effective way to protect groundwater. Groundwater is extremely expensive. You basically have to suck out all the water, purify it, then pump the water back into the ground before it can be used again as far as cleanup goes. Prevention is the only way of really helping out and saving ourselves long term with groundwater. Here's some solutions. Find some substitutes for toxic chemicals so they can't get into groundwater. Keep toxic chemicals out of the environment. Install monitoring wells around your home where your wells are, so you can sense if there's any problem with the water being pulled up from that. Requiring leak detectors on underground tanks, banning hazardous waste disposal in landfills and injection wells, and storing harmful liquids in above ground tanks with leak detection and collection systems. Cleanup, though, it's just basically pumped to the surface, clean it, and then return it to the aquifer. It's the most expensive and very costly to clean up. Inject microorganisms to clean the contamination for you. It's less expensive, but still costly, and we don't know if it works 100% of the time. And pumping nanoparticles of inorganic compounds to remove pollutants, again, still being developed, hasn't been fully tested, and doesn't quite work fully yet. There are many ways to purify drinking water. Reservoirs and purification plants, process sewer water into drinking water by a three-step, major filtering methods, also using chemicals. Expose clear plastic containers to sunlight, which is UV radiation, which would kill off bacteria. Use nanofilters, and my favorite is actually the Life Straw. Life Straw is shown here. It's mostly made for developing countries as a personal water purification device. It basically has a filter through here. You can take this to the river, drink from it, and it pulls out different bacterial contaminants as well as other things to help when the water gets all the way through being purified into your system. So really, really great for third world countries, especially in areas where there's a lot of contamination in rivers and low decalinic systems. So one case study is protecting the watershed instead of building water for purification plants, and that was done in New York. The New York City water is best known. It says New York City drinking water is known for its purity. It gets 90% of the water for its 9 million residents from reservoirs in the Catskill Mountains. Forests cover 3/4 of the West watershed, and underground tunnels transport the water to the city. So instead of actually purifying the water that's in the city, they actually do pump it from a more pristine area. And that's helped to protect the watershed instead of just using and relying on those purification plants. It says the continue providing quality water for its citizens. The city faced the spending of $6 billion to build water purification facilities. Instead, the city decided to go negotiate an agreement with towns, farmers, and state and other interests in Catskills watershed, and the city would pay this diverse group of governments and private citizens $1.5 billion over 10 years for protecting and restoring the forests, wetlands, and streams and watersheds. That way, New York City could have clean water for the members of that city. Another big act is the 1974 U.S. Safe Drinking Water Act. It sets maximum contaminant levels of pollutants for any pollutants that affect human health. People think they should strengthen the law. In what ways? Many different ways. They think they should strengthen it because despite passing the Clean Water Act, we still have 5.6 million Americans that do not meet the EPA safety standards for one or more contaminants. So we still need to strengthen it even further and work and maybe impose heavier fines on people like water bottling companies and even townships that are not purifying their water fully. Water polluting companies weaken the law. Obviously they want to weaken the law so they can pollute more and deal with their waste even more. Bottled water. Is bottled water the answer? And a lot of people ask this question, like, how do you drink bottled water? Some of the clean in the U.S. has some of the cleanest drinking water, but still we use bottled water rather than other places in the world like they have to. But some is from tap water. 40% of bacterial contamination is actually in bottled water, which is kind of a scary thought. Fuel costs to manufacture the plastic bottles. So just to make plastic bottles, it takes fuel and petroleum. And then recycling the plastic, I do something with that afterwards. I personally don't like bottled water. Occasionally I'll drink it, but usually I drink in the form of this one. It's an Nalgene. It's a heavy plastic, and it's a very durable plastic, although it's still made out of oil, but at least it's long lasting. For me, and if I use it over and over again, it kind of equals out in the value of it as far as the environment goes in my mind. So what I do is I just use this tap water. If I need to use a Brita or something like that to filter out, that's not nearly as bad as having to make those plastic bottles over and over again. So I just use this, refill this, and actually it is lined with an antibacterial agent that basically keeps the bacteria out of my water, which is very nice for me so I can drink it and stay healthy. There is also a lot of growing to the back to tap movement, which is basically kind of what this is, kind of still using drinking water because water itself is kind of overpriced and just put it in a bottle, and also all the plastics needed to make it. So that's the end of looking at groundwater. Hopefully you guys got a little bit out of that. I'm going to post some videos about that are up on YouTube about this in the bonus section, so check those out. We'll see you guys next time for 2.4, which is water pollution affecting the oceans. See you guys next time.